All right, today 4.4 notes day one. Student handout here you can get, but again, teacher edition right here. So when we talk about today, this should not be Alabama paradox. I will reload this one in. Give me 1 second to make that fix. Okay, so this should be a little bit better now. Get my pointer out of the way. And 4.4 notes. I know it says part one, part two. We're going to do both of those today. So basically, the first part is a review of division and fraction math. So I'd like you to take a look. The answers are here. Um, and so you can go through and kind of do the proportions and how you actually solve those. And then we go into section 4.4, which is the Jefferson method, and making sure that I get everything. Okay, so couple of things to go over here for the Jefferson method. So this is the new method that we have, and so Jefferson's method's goal is to make a bigger modified quota so that there are lower quotas will be an exact apportionment. And essentially, we're kind of forgetting about Hamilton's method here and just focusing in on Jefferson's method. So Jefferson's method, we calculate the standard divisor. We find a suitable modified divisor, which we'll abbreviate as MD, such that the sum of the lower quotas is the number of seats. So whatever that difference was, now the modified divisor gives us that. So this is going to end up being an exact apportionment with no surplus. So you might be asking yourself, how do I find that, right, modified divisor? So originally guess should be reasonably less than the standard divisor. So if we're guessing what it is, it needs to be less than that standard divisor. So our current total of lower quotas is always going to be less than the exact number of seats in the apportionment. That will make a smaller modified divisor. Our current total of the lower quotas is greater than the exact number of seats, then we need to make a larger modified divisor. Essentially, if it's less, make it smaller. If it's more, make it larger. Makes sense. Kind of here's a flow chart of guessing what that modified divisor will be, right? So modified divisor, if it's smaller, then we know that the total is less than. If we know that it's exact, it's equal to, and if it's larger, we know that the total is greater than the modified divisor. So one, calculate the sum of the lower quotas with the modified divisor, compute the current total T versus the number of seats M, and then follow the flow chart, boom, boom, whichever one it is, and then redo until you found a suitable modified divisor. Examples of the usage. So assume we have a number of 40 seats, right? And so our lower quota totals would be 39. So because 39 is less than 40, right, we know that our modified divisor can be something less. So then we're going to have less than, right, the number of seats. Our T is less than. So we need to change out what the modified divisor is. And so maybe 35 could be our modified divisor. For if the total number of seats added together from the lower quota is greater than 40, then we need our modified divisor to be greater than. So T is greater than M. But if our modified divisor is 40 seats, then we need it to be exactly equal. So you can see where we're going to get those numbers out from. Now, again, if the number of seats is 150, the modified divisor, we double check, right? So however many there are until we get exactly 150 seats added all together. Okay. So if we were going to do, again, some guessing divisors, use previous divisor statements to assist. If a divisor is 100, created over apportionment, and the divisor is 105, created a below apportionment, the next guess should be between those two. Again, we're just doing a guess and check game. So you can look at kind of the mathematical process that goes here through 2 and 3 and pause that if you need to. So we're going to look at one example here in the part one. And example one says a performing Jefferson's method. So we're going to perform Jefferson's method here. It says there are 15 scholarships to be apportioned among 231 English majors, 502 history, and 355 psychology majors. States are the department, seats, scholarships, population, number of majors. So again, taking a look here. Now, the total is 1,088. So technically, 72.53 is our standard divisor. The problem is, when I add everything up, we get 15, which is fine, but the lower quotas give us a 13, which is smaller than our standard. So if the lower quota sum is smaller than the standard quota, now we need to pick a smaller standard quota. So 13 total new seats is smaller than 15. That's a problem. Therefore, we need to pick one that's smaller. So try 72. The new modified divisor should be smaller than what we had before. So when I do that, we don't worry about the total here because we're just looking at our lower quotas. So again, smaller. That's a problem. So now it's still smaller. Let's go even lower. Now try 70. Why did I try 70? Well, because it's still smaller than 72 and smaller than 72.53. So when I do that and I do my lower quota, now 15 is exact, and 15 work. So you might have a decimal standard or a new modified quota that's different from somebody else because all we're doing is looking at the rounded down portion. So a modified divisor of 70 is able to give me an exact apportionment of 15 using Jefferson's method. And again, we just kept going down on the standard divisor. So are there any other modified divisors smaller than 72 that we could have had? Yes, There's a range of possible divisors that will round to the apportionment of 7, 3, and 5. So there is a possibility of that. If you need some more help on this, coming down to example 2 and 3 and 4, there's a bunch to look at here. So I want you to take a look at those. You've seen the basic outlines. Read through these. I know there's a lot of reading, but read through them and see what we can come up with, okay?